Okay, so one of the most important things about graphing exponential functions with transformations is being able to understand what the equation is telling you to do and whether or not you're reading it right. So this is just going to be a quick overview on what each transformation represents and how to read each function. Okay, so starting off with y equals 2 to the exponent negative x. So that negative is being applied to the x values. And whenever we apply a negative to an x value, that means there's a reflection on the y-axis. This should be a rule that you're familiar with, that when you're multiplying your x values by a negative x, there is a reflection on the y-axis. Okay, it's the opposite. If you're multiplying your y values by a negative 1, there's a reflection on the x-axis. If you multiply your x values by a negative 1, there's a reflection on the y-axis. Or I should be saying over the y-axis instead. Okay, and horizontal asymptotes is another key component we should understand for exponential functions. And we know that horizontal asymptotes are only changed when there's a vertical shift. And in this case, there is no vertical shift. So my horizontal asymptote is still going to stay the same. So it's still going to be y equals 0. Okay, moving on to the next one. I have y equals 3, 2 to the exponent x. That 2 has the exponent x, not the 3. So whatever has the exponent is your base. Okay, so 2 is the base, and 3 is added to this equation. And the number that comes before your base value is your vertical stretch value. So that 3 relates to your vertical stretch, your y values. So that 3 is going to be a vertical stretch by a factor of 3. So that just means your y values are being multiplied by 3. And that's the only thing happening here. Okay, so now let's look at our horizontal asymptote. We know for basic exponential function, the horizontal asymptote is at y equals 0. Okay, but in this case, my y values are being multiplied by 3. So what's 0 times 3? Well, it's just 0. So your horizontal asymptote did not change. It's still going to be at y equals 0. Because we also know that the only thing that can affect my horizontal asymptote is a vertical shift. And we don't have that in this case either. So that's the only thing happening there. For the next one, I have y equals negative 2x. Okay, that negative is in front of your base value. Okay, so whatever is in front of your base value deals with your y values. So my y values are being multiplied by a negative, or you could say by a negative 1. Okay, so when my y values are being multiplied by a negative 1, that means that there's a reflection over the x-axis. Like I mentioned before, it's the opposite. Okay, so I'm going to have a reflection over the x-axis. Okay, and that's the only thing happening there. And for my horizontal asymptote, there's no vertical shift happening, so I know my asymptote is still going to stay the same. You can try multiplying that y equals 0 by the negative, but it's still going to be 0. You can't have negative 0. Okay, so for the next one, y equals 2 to the exponent 3 of x. Okay, that 3 of x, that 3 right there is your b value. And your b value deals with your x values. At the end of this, I'm going to give us an equation to remember our values. But that 3 is our b value, and our b value deals with our x values. And we know that whatever our b value is, whatever we do mathematically is going to be the opposite. So we have to reciprocate that 3 and make it the opposite. So, and that's a horizontal stretch because you're multiplying your x values by something. So it's going to be a horizontal stretch by a factor of 1/3, because I have to flip that b value because it has to be the opposite. Okay, so that's the only thing that's happening there. Everything else is still the same. And for my horizontal asymptote, there's no vertical shift in this equation, so it's still going to be the same. It's still going to be y equals 0. Okay, so for the next one, I have y equals 2 to the exponent x minus 1. Okay, that x minus 1 is in the exponent, and that is my c value. And my c value deals with my horizontal shifts. Okay, and I know that my c value and b value are always the values that are going to be the opposite of what you do mathematically. So if I have a -1, mathematically, I'm going to be adding 1. It has to be the opposite. Okay, so I'm adding 1 to my x values. Another way to say that is that there's a horizontal shift, 1 unit to the right, because +1 on a graph means 1 unit to the right. So there's a horizontal shift, 1 unit right. That's the only thing happening there. And once again, there is no vertical shift in this equation, so your horizontal asymptote is still going to stay the same, y equals 0. Okay, last one. I have y equals 2 to the exponent x minus 1. Okay, that -1 is your d value or your k value. So your d value deals with your y values, and specifically it deals with your vertical shift. Okay, so that's your vertical shift right there, and it's 1 unit down your graph. So it's a vertical shift 1 unit down. Okay, and now let's look at our horizontal asymptote. Something's going to change here. For whenever you have any basic exponential function, you have an asymptote at y equals 0, unless there's a vertical shift. And in this case, there is a vertical shift, and it's 1 unit down. So if you had a horizontal asymptote at y equals 0, and you shift it 1 unit down, now you're going to have a horizontal asymptote at y equals -1. And so in this case, your asymptote changed. Okay, and now I'm just going to give you a basic equation to remember that'll help determine what your a is, your b is, and whatnot. And that is y is going to equal, how should I write this? Okay, so you're going to have an a value, then you're going to have a base, and in this case the base was 2, and that base is going to be to the power of b x minus c, and then you're going to have plus k. And that's your basic equation for exponential functions. And remember that your b and c value always have to be the opposite of what they are when you apply them mathematically.